All right. Last thing, let's do a couple of quick plots. So part of this just goes back and sort of sets some things back up. So we've already calculated these above. Now that we have that data, we can make a histogram of it. So histogram, there's some nice basic default graphics in SPSS for doing just exploratory statistics. And a histogram is a great one. So if I look at the histogram, it looks kind of weird. But remember, I had that weird typo for height, so we need to go back and fix that. I encourage you, yes, there are ways to go in and manually edit the data file, but I caution you against it because sometimes as soon as you do that, then you forget why you did something. So, like, I could actually put, you know, fixing typo in height for subject 18, data was 2.6, this should be 5.6. And the reason I point this out, this is pretty simple, and yes, it's easy, but suppose you've got 80% of your sample, people recorded everything in pounds, but then there was a subsample that was done, let's say at the VA, and they recorded everything in centimeters. So as soon as you look at it, you're like, so you have to go through and you just make a quick list. Okay, these are the people who were recorded in centimeters. This is the conversion. This is how we fixed it. You know, and sometimes we do that on the fly. We might do it manually and fix the table. But it's really nice to have that annotation so that 3 months from now, we're doing the final report and there's an audit. And you're like, okay, why did we change this again? I mean, that one's pretty obvious, but sometimes it's not so obvious. There's other things we run into and we make corrections or decisions on the fly, and it's helpful to keep track of that. So this would be that correction. So we're selecting 18, and you'll notice I could have gone in and figured out which column height was, but since it has a variable name, I can just call it. So if I put in quotes the word height, it says go and find the height variable, find subject 18, in this case row 18, and I'm going to change just that one number to 5.6. Yes. Yes. Yes, so, and I haven't gotten into selection, but you're exactly right. So I could say, let's see, data.csv, trying to think how to do this. Let's see. So if let's just say right now, okay, let's just look at the height and find everybody who's less than 5 feet tall. So it would go through and say false, 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 false. So this is row 18, 1920. So that's kind of one way to do it. I could say, okay, find row. I could actually encapsulate that, which is basically that true-false indicator. So it's creating sort of that logic vector, and I could call that find row, and then I could take that information in data.csv and say, you know, find the row in height. So if I run that, creates the find row, which is that vector. Now it's going to put everything in, and the only value that would show up is the value for which that row was true. So there it is. So it goes and actually finds that value. So that's one way to do it. I just sort of simplified it. But there's all kinds of things that you could do here for data selection. So let me just make a note. We could also use logic to find the height that was too low. Then use that logic vector to select only the row that was true. So good question. All right, so if I come in here and reassign it, that's going to fix it. If I want to double check, I can open the data table, scroll down, look, row 18, it now says 5.6. And I need to go back and make my correction. So I'm going to recorrect BMI pre, BMI post, because the height affects both. And then I'm going to redo that histogram. And the last thing that I added here was frequency is false. So you'll notice that in this first histogram, I did it based on the counts, so it's giving me frequencies. I can turn the frequencies off and just look at it based on density, so the proportion. So everything here scaled from like 0 to 1. And the reason I did that is I wanted to show you guys this little thing called density. This will actually go through and look, it does a non-parametric curve estimation for a histogram, which is kind of cool. And then I'm overlaying that using the lines command. So when I do that, instead of overlaying the normal curve, I can overlay that. Sometimes this is kind of interesting, especially if you have something that's bimodal or something that's kind of skewed and you're really kind of wanting to see where the density of the data is. So I just put that one in there so you could see that function. The last one that I'm going to do here is a scatter plot. So I've got X and Y, so I'm going to look at the pre-weight and the post-weight. So these should be almost perfectly linear. I put a little P here to say just show me the points. So there's the plot, BMI pre. And yes, we could change all the labels. We'll come back to that. We'll do a little bit more on graphing later. So this is fairly linear. Not many people changed a whole lot. So I could actually, in this command, the LM command, I'll talk more about this in Workshop 4, that's actually stands for linear model. So I'm doing a little miniature linear regression and looking at the post-weight being predicted by the pre-weight. And I want to put that best fit line, overlay it on that plot as red. And so the AB line command, what that's actually doing is it's going in and pulling out the y-intercept and the slope from that linear regression. So I'm actually running a linear regression, fitting that line, and then overlaying it. And so that's what this one does. And then the last one, if I wanted to, I could also do what's called a low-S, which is a non-parametric best fit line. It's basically drawing a smooth line through the points. And same kind of thing, I'm going to color it blue and I'm going to use the lines command to overlay that. So these are kind of handy things to do, and this is something that while you can do it in SPSS, it's hard to automate this in SPSS. So even if I can automate the graph command to make the scatter plot, it's very difficult, or at least I haven't figured it out yet, how to tell it on the fly to overlay these lines. I can go in and open the graph window and add these kinds of models and fits and stuff to the window, but trying to figure out how to do it on the fly sometimes gets complicated. So, all right. So that was essentially most of what I was going to show you guys today. So what else would you like to see, or are there any additional questions? Is there something you'd like me to go back and clarify? I mean, we've got a few minutes.
So can you save the graph then?
Yes. So I've zoomed it out here just so you could see it a little bit better. But inside here, there's an export, and I can tell it to save it out as an image. And from here, you can save it as PNG, JPEG, TIFF, bitmap, metafile, support vector graphics, encapsulated PostScript. You can give it a file name. You can change your directory. There's some tweaking you can do here based on the size. So suppose I save this out as a PNG file. Say save. Then I could open, let's see, where's my apps? I'm still getting used to Windows 10. So Microsoft Office, let's see, let's open PowerPoint. Sorry, with Camtasia it's always wanting to be helpful and with recording. Where's the slide? Okay, layout. Let's just make it blank. Okay, so now that I've saved that, I could actually come in here and say, okay, I want to go find that picture I just saved. It was in wherever I put it. My R Spring. I think that's the one I just made. So I can bring it in that way. I could also, with R Open, so I could say export and say copy to clipboard. I think it automatically defaults to, okay, so it's asking me, do I want to copy it over as a bitmap or a metafile? Bitmap is sort of pixely looking. because it's literally saving every pixel on the screen. Most of the time, most of the stuff I'm doing, I'd probably do it as a meta file and then say copy plot and then go back to PowerPoint and say paste. I could just use default. I like using the paste special because then it'll tell me it's not giving me many options. We'll just bring it in as the enhanced meta file. Oh, I'll tell you what, let's do it as the other one. Windows meta file. Whatever. I don't know why it always adds the extra white space, but it does. So if I crop that out and then grab the file. And this is really handy. So I'll mention this to you guys as you're getting ready for SNRS. Meta files are awesome because you can just scale them and scale them and scale them and within reason. You know, so if it looks this big on your screen, but when you print it out poster size, meta files usually scale pretty well. There's some limited ability to do this in SPSS, but R and SAS and stuff have better graphics handling. So, yes, so we could do the labels, and I'm trying to remember if I can do this without redrawing it. Let's see. What can I? Let me see if it'll let me just do that. Yeah, yeah, I think I have to do it back inside this plot command. So if I'm here and then so I know I can do it here, and then I could have a main title, compare BMI pre and post. So if I did that and just grab all of these commands and run it again, yeah, it'll add it.